My name is Andrew Nguyen, and this is my first Clojure West, so hopefully this is somewhat in line with what you guys are expecting to hear. And I think the schedule says body data systems for the company. We recently went through a name change, and so that's what you see on the screen is Clara Health. And then first, just thanks to Alex and Lynn and everybody at Cognitech for putting on a great event so far, and happy to be here. Basically, I'm here to talk about kind of how we're using Clojure and ClojureScript in healthcare big data, but I put big really in a really small font because to us, big data in healthcare is really 1,000 little data problems. I haven't been able to find the source of it, but I was told that the average patient electronic medical record is only about 1 to 3 megabytes. And so discounting images and videos and whatnot, there's really not a lot of data. It's just a variety of it. And so a little bit about myself. I recently finished a PhD in medical informatics at UC San Francisco, and my thesis was on biometric and physiological sensor data, analytics, and mostly waveform data in the intensive care environment. And then kind of through that process and through that work, became acutely aware of the need to normalize and harmonize healthcare data and whatever's coming out of electronic medical record. Just quickly, in terms of the audience, how many people here have a background in healthcare or have done healthcare? Okay. And then in terms of the software side, I spent a lot of time in embedded software and defense aerospace, wireless semiconductors. And then in terms of the healthcare and informatics side of it, did a lot of work in Hadoop and semantic computing in general and web application development. And quickly about the company, kind of the startup, our goal is to bring clarity to healthcare and pretty much through the data. And our lead product right now is the MyView electronic medical record interface. And the idea behind it is to make it really easy for physicians, nurses, administrators, anybody in healthcare to have access to relevant patient data and customize the view of patient data from any patient within our network. And the goal is to make electronic medical records better. We overlay any EMR system, so we're not intending to replace them, and then make health information exchanges unnecessary. And so what's the problem that we're solving? Really, for us, it's difficult to access relevant patient information from electronic medical record systems, even within a single organization. So a doctor sits down and says, what did I do to my patient last week? And what do I need to be thinking about to treat them today? And that's not as easy as it should be. And then if you're trying to pull data from different sources, so the hospital down the street or a clinic across the country, it's virtually impossible right now to do so at scale and in a way where you're getting what you want instead of having to hunt and peck for everything. And so why is it so hard? The problem that we see in healthcare, it's fourfold. We're trying to communicate the same thing in different ways. And so, simple example, where a lot of times we just call it a heart attack. Doctors call it a myocardial infarction. You look in the notes and there's a bunch of abbreviations, AMI, and these all encompass the same concept most of the time. And when you look through it though, it just looks a bunch of different ways, and how do we tell computers what this means? And then if we look at it, we're also trying to communicate different things the same way. And so something as simple as a patient encounter, a doctor and a patient sit in a room together, there's an encounter, but is it really an outpatient visit? Is it a hospital admission where you got admitted one day and discharged 2 weeks later? Or is it a procedure, right? A surgical procedure sometimes is referred to as an encounter. And then we're trying to do the same things with different data. So something that's common right now in the industry is looking at hospital readmissions. So did you come back to the hospital for something that should have been treated or could have been treated? And if you look at it from the hospital perspective, they're usually trying to answer this by looking at electronic medical record data. But insurance companies who don't have access to that data, they're asking the same questions, but they're only looking at claims. And that's just one simple example. And then we're trying to do different things with the same data. And so there's a lot of electronic medical records out there. There's a bunch of patient data sitting in there. And one doctor may look in it and say, you know what, I want to set up a trigger or report of some sort that lets me send out notices to parents and reminding them that their kid should come in for a booster shot for immunizations or something. And at the same time, we're trying to use that data to do resource management, supply chain, make sure that we have enough vaccines on order. And so we're all trying to use the same data, but we're doing very different things with it. And so back to this example of an encounter. Let's say you're a patient, you get admitted to a hospital for 2 weeks, and there's 3 surgical procedures during that time frame. Simple question to ask is, how many encounters is this? And this forms sort of it's an example of a basic query that we want to ask of the data. It forms a unit of measure, right? And if you talk to a hospitalist or an inpatient doc, they'll say it's one encounter. Patient got admitted on one day, got discharged 2 weeks later. You talk to a surgeon and they say, well, it's 3 encounters because they came into my OR 3 times. And to make it a little bit more complicated, what if the second and third surgeries were just extensions of the first? And so are those separate encounters? Is it one encounter? Is it one episode of care? And so up until now, how did the industry approach this? Basically, it was let's build custom solutions for everything. Every hospital out there gets its own little system, and within a department, sometimes you have different systems for the ER, for the OR, for psychiatry, pretty much everything. And then clinics, if you look at outpatient clinics versus hospitals, and we've gotten into a habit of basically just building custom solutions for every possible use case out there. Even within a single department, you oftentimes see multiple competing systems that do slightly different things. And it's pretty much the reason why there's a ton of data silos. There were a lot to begin with, and we keep making more of them as we try to actually leverage and use this data. And one of the stats that surprised me the first time I learned about it is if you look at a medium to large hospital, so this is like 600 to 1,000 beds, there's upwards of 400 different data systems. And I was talking to a guy at one of the hospital systems in California, and across all their hospitals, they have over 2,500 different databases and vendors that they're trying to aggregate data from. And so how are we trying to handle this now that there are all these silos? And basically, let's push interoperability, and let's get everyone to agree on how to capture, store, exchange, and interpret healthcare data. And as engineers, I'm sure you're all aware how you capture and how you store data is oftentimes dependent on how you're going to use that data. And so then it comes down to interpretation. And one of the things that we're focused on as a company is that part of the process. How do we interpret healthcare data? And from an interoperability standpoint, if we look at kind of HIMSS definition, they're the major trade organization that encompasses healthcare IT. They break it down into 3 steps. The first is foundational. So this is the ability to communicate between systems. And so at this point in the game, we have things like XML, JSON, REST, and a handful of others that allow us to physically send data back and forth. And then on top of this, you can build some sort of structural interoperability. And in healthcare, there's the HL7 standard. It allows us to at least know what we're sending. There's an API coming out of Harvard that's called SMART, and that provides some sort of uniform access to healthcare data. And then on top of all this is the semantic side of it. So the National Library of Medicine curates this UMLS, which is a collection of vocabularies, terminologies, and whatnot. And this is sort of where I've always been focused and where my interests have been. And the definition I like to use for semantics, and the sub part of that is the interpretation of the meaning of a word, or in this case, a medical concept or a clinical note or a data element of some sort within a database. And so that interpretation ends up becoming a highly contextual process. It depends on who's asking that. You have doctors, right? Cardiologists probably not going to interpret data the same way an OBGYN would. And then you have patients and their caregivers, parents and whatnot that are trying to look at this data. And then what are you looking at? Are you looking at patient records? Are you looking at stuff out of the electronic medical record? Or is it claims information? Or something coming out of a bedside monitor, an EKG or some sort of sensor? And then now there's a whole lot more patient-generated data between wearables and Fitbits and just people tracking a lot of stuff on their own. And how do you interpret that? And then why are you looking at that data? The most obvious one is patient care, right? Doctors, nurses, pharmacists, and whatnot are always looking at this data to treat patients better. But as an organization or as an industry, there's a move towards population health where you're trying to aggregate data across multiple patient populations to target the sickest or the most expensive and see what we can do to drive down costs or just improve health overall. And then there's always predictive analytics. It'd be nice to know if we can predict when something bad's going to happen and prevent that. And then how are you looking at this data? Is it a clinical workstation that, I don't know if you've been to the doctor recently, but pretty much the person sits at a computer the entire time while you're talking to them. And then you have analytics algorithms where normalization is really important. And then generating reports for the administrative level or trying to exchange data between hospitals or different organizations within the healthcare continuum. And then where is this happening? Is it in a hospital? Is it an outpatient clinic? Insurance companies. The big one too is geographic, or the difference between urban and rural medical centers. The environment plays a big factor in health, and so do demographics. And so how does this affect the interpretation of data? And so how do we get everyone to agree on semantics? It shouldn't be too difficult until you look at the numbers. There's 300 million patients. There's anywhere from 2.5 to 3 million nurses out there, and over 800,000 physicians. And they're spread over 6,000 hospitals. If you look at the electronic medical record vendor industry, there's a federal mandate to certify EMRs, and as of stage 1, there were over 900 certified EMRs. And part of stage 2, that number's dropped to about 70 or 80, and it's an ongoing process, so there's probably gonna be more, but you have almost 1,000 different vendors providing centralized electronic medical records. And then you have thousands of other vendors providing OR scheduling systems, ER management, labs, pharmacy, billing, and kind of the list goes on forever. And then you have insurance companies, kind of everybody else in healthcare. Outside of the hospital, you have insurance companies, medical device companies, private practices. My parents were in the dental field, and pretty much not a lot of people are looking at dentistry from a data standpoint in healthcare. And our perspective on this is you can't really get everybody to agree, so don't try. But can we design a system that embraces that inherent dissonance and somehow enable a mass customization on top of that? And somewhat synonymous with building a customizable and dynamic system, but standardized enough that we can repeat it and scale it across the industry. And so our approach to this is to leave data in its native form. We don't want to alter the data because a lot of times you change data, you want to go back, you learn something new about the patient or something better on how to interpret that data, and you've already changed it. And so with that, basically this contextual on-demand translation of the data. So can we do what we need with the data without changing the raw source form of that? And can we deploy this as an on-premise solution? A lot of hospitals want to be able to control the data, or for those that don't have the resources to do so, can we deploy it into a HIPAA-compliant cloud? But the key, regardless, is to manage everything from the cloud. And what this does, it allows us to make it repeatable and scalable. And especially given that we're just a startup trying to tap into the enterprise healthcare market. And so this is a quick screenshot of our MyView interface right now. It's just there to show that we can group all the data together and kind of provide a concrete example of one example of what we want to do with that data. And so the big question is, how do we make that a highly customizable and dynamic system, but make it repeatable and scalable? And so we discovered Clojure about 6 months ago and had been using a lot of Java before that, and it's become an important part of our toolkit. And just some quick background, basically we were doing a lot of Java, and then we started doing some Groovy, and mostly because the existing ecosystem has a lot of Java, a lot of it runs on the JVM. And about 6 to 7 months ago, we started to play with Clojure, mostly just experimentation, futzing around with it. And then 5 months ago, we started using it pretty exclusively. And then ClojureScript about the last 2 months. And we've ported quite a bit of our code. Pretty much all of the Java and Groovy's been ported over, and that was way faster and more painless than we had expected it to be. The CoffeeScript and ClojureScript side of it, we're still learning, and I have some questions about that later. And so how did we get there? We started with Java, as I said, went to Groovy because we didn't really like Java. And then we started experimenting with Clojure when we started playing around with Hadoop and Cascalog. We do a lot of Hadoop on the back end, and Cascalog looked interesting, and so I figured this may be a good time to start learning. And once we started playing around with Clojure, we realized we really liked it and liked what we could accomplish with it mostly. And so we decided to take a stab and see if we can commit to it and see what that would look like. And so one of the three main reasons we went to it was dynamic development and the repl, and being able to interface with it. And it sounded really cool, but we kind of had doubts. In terms of background, we came from assembly, C, C++, Java. And so this was a very foreign workflow for us. It was fundamentally different, and we had to learn how to work with it and how to move away from kind of the traditional mechanisms of testing and iteration that we were used to. But what it did was it enabled really fast prototyping and experimentation for us. We could futz around, try something, see what happened, add to it, and keep on adding to it, and the next thing you know, you have a functional part of your project done. And that also made it really easy for us to learn and experiment with new APIs. I don't have any numbers on it, but in terms of how many more libraries I've experimented with in the past 6 months has gone up quite a bit. And I think that's largely due to the fact that it's okay to experiment, and it doesn't cost a lot of time or take a lot of effort to pull in a new library and see what happens and what we can do with it. And some things that we noticed in terms of trying to keep an eye on it, basically these are things that bit us in the ass. And it was really easy to create complex one-liners, and if somebody kind of goes off and does something and comes back a couple weeks later, it all works, it looks really cool, then you forget about it, and then about 3 weeks later you go back and try to fix something. And you spend a lot of time just trying to figure out what went on. And when we looked into it, it was a lot of iterative experimentation. You try something out, you add a little bit to it, you keep adding little bits to it, and the next thing you know, you have 2 lines of code that do a whole lot. And part of that also was it's easy to get away with not documenting, because developers just say, well, if you need to, look at the code and it's all there for you. And my code is self-documenting because I chose really good names for everything. But it's not always the case. And then not really a dynamic development issue, but one thing we noticed was macros are tempting but risky because they create time bombs, especially when interacting with other APIs or other people's code. Unless you spend a lot of time vetting all of the code you're bringing in, you end up getting unknown interactions, and those interactions create really weird effects. And then I heard this a lot at first. It seemed whatever, but I've come to appreciate it a lot in terms of code is data and data is code. And for us specifically, because we have a system where we're trying to pull in these semantic rules or even syntactic in nature of how do we massage data, how do we pull it together and be able to compare different data sets, we needed to deploy what we call data rules that are a runtime thing. We deploy our system, and then we need to go in and change some of these rules around. And this idea of code as data is just very helpful for us as an abstraction or as a way to think about what we're doing. And functionally, it's great too. And everything's a function, and so we can test these functions pretty easily outside of the system, have a high confidence that they're not going to break anything, and be able to deploy them and manage this process. And so it really simplifies how we deploy our data rules and how we're able to basically blur the lines between what's being done traditionally as a compile time task and what's being pushed out to runtime, or we'll deal with it later. And then the other cool thing for us was the close integration on the JVM. We pretty much didn't have any trouble calling Java or Groovy stuff from Clojure. We didn't have any major problems, and since the original attempts at Clojure, we've ported all of our Groovy code, and all that's remaining now is Java code that we're interfacing with in terms of third-party stuff. One of the things we're still learning, though, is how do we translate kind of from this object-oriented approach to a more functional one. And this is true with a lot of existing libraries that expect you to create this one instance of a class, and then you just keep doing stuff to it over time, and then sometime down the line you call this run or do it function of some sort, and all this magic happens. And how do we encapsulate that into a more functional approach? And something we're still learning and experimenting with just to find out what the best way to do that is. One thing we have not tried at all is to go the other way, is to call Clojure code from Java or Groovy. And we do notice that we have a lot of hyphens in our namespaces. And so maybe that's one of the reasons why we're trying to commit to Clojure completely. And then for whatever reason, it was just a lot of fun. And I don't know if it's just a combination of all of the above, but it didn't feel as difficult or as tedious to learn new APIs or to integrate or to take on bigger and bigger challenges. And as a result, it was just a lot more fun for me to develop. In terms of the stack, I'm not going to go through all these libraries, but generally this is what we're using. We have a graph database that we're using with the Blueprints API. We have a Mongo instance. We're using RabbitMQ underneath a lot of it. And then we're starting to look at Datomic, but we haven't done anything with it. And then kind of your standard web stack, and then associated libraries to make the coding life a little easier and how we test. And so in terms of looking at what libraries we're using, the first and most important thing for us was how easy is it to use. There's so many options out there, and there's always do we get one, especially if we're trying to wrap an existing Java project of some sort, do we use one of these wrappers somebody else created? Do we create our own wrapper because it's really not that much work, or do we just not wrap it at all and try to interact with the Java directly? And so the first thing was, is it easy to use? And then second, is it easy to maintain? Projects come and go, and if need be, how much effort would it take for us to take over that project internally? And then it'd be nice if it was an active project that we didn't have to worry about adding features and whatnot too. Overall, we had a couple other things we considered, which was how many dependencies were there in the project that we were pulling in, how verbose was that API. Two things we learned is a lot of projects out there. So there's always that balance between, do you reinvent the wheel or do you pull in an existing project? And sometimes we found these really simple libraries that pulled in like 20 or 30 other projects. And it just became a big nightmare to maintain and make sure that we had all the libraries set up so that we knew what was going on and what was happening, especially once we start deploying these in large-scale production. And then, did it make sense overall? Some of the APIs we found, I don't know if it's because we were new to Clojure and kind of what's idiomatic and what's not, but it seemed like a really weird way or really convoluted way to accomplish something simple. And so that made us stay away from some projects. And then overall, did it fit with our general coding philosophy? This was not as important to us because we know we're still learning, and what we think is best now may not be, and vice versa. And then one thing we really disliked was hidden dynamic bindings or state kind of in the background that was just hiding there. Some of the comparisons I'll go over is, so we started with clojure.test, and then we ended up migrating away from that. And partially because the failure output was easier to understand for us. And auto tests surprisingly increase our developer productivity more than we expected. And especially when trying to convince people to add all the other test cases to round out your test suite. And the ability to just keep adding that and watch the little auto test say all your tests are succeeding, I think was a positive feedback loop that people were able to really add all the tests they should. And then one thing that we noticed with clojure.test was that the fixtures seemed to be a little bit less verbose. And this could just be that we don't fully understand our tools yet, but we do a lot of testing where we're interacting with databases. And so being able to set up and take down that process was important to us. And the migration away from clojure.test was sort of difficult when we were trying to learn that initially. And so we were using core.type. Coming from the C world, we wanted some sort of type system in place because it made us feel safer. And core.type seemed to be exactly what we wanted. But we noticed once we started using it, we started sprinkling these no checks everywhere. And it seemed like we were doing that more often than not. And so the big question was, why are we doing type checking? Or what do we want out of that? And really it came down to, we wanted to ensure that the maps and vectors we were passing around had a certain structure to it. And so once we thought about it that way, schema seemed to fit our current needs and be less verbose and easier to integrate into our workflow and our code base. But one of the cool things is, if and when we need a stronger typing system of some sort, there's no reason why we couldn't integrate the two together. And then on the web stack side, we chose to use enlive instead of hiccup or clostache or any of the other templating libraries. And it came down to a matter of coding philosophy and style. We wanted to be able to have 100% HTML templates that looked real, even when you were using these or interacting with them outside of the rest of the stack. And part of that was because we were working closely with physicians, nurses, other domain experts who are non-technical, and being able to just have something that looked real and work through that process really quickly, and then hand that off and not have to do anything else to actually get it to run was very powerful for us. Basically, it provided for our workflow a cleaner abstraction between the how it looks and how it works side of the coin. And it happened to fit well with how we were using Knockout from when we were doing a lot of this in a previous iteration of the product. And that's not to say that other things wouldn't integrate well. It's sort of an observation for us. And then in terms of the ClojureScript side, background, we're about a 70-30 split right now. We're starting to do new stuff in ClojureScript. And we have a lot of existing CoffeeScript that we're afraid to port over just yet. And in terms of prior experience, we have a smattering of experience with various frameworks and toolkits and whatnot. And so we started with JavaScript, moved to CoffeeScript, and then went on to ClojureScript, mostly because we really liked what we could do with Clojure on the back end and wanted to see, if it carried through with the front end stuff. And then we discovered CLJX or ClojX or however you pronounce it, in order to be able to share code between the front end and back end pretty easily. In terms of our stack on this side, it's a lot smaller. Pretty much we're just wrapping a lot of jQuery, and then we're using core.async, and then your same schema and test and whatnot. And so we're using async on both the front and the back end, both in Clojure and ClojureScript. And it's really just to simplify the messaging and job coordination, and being able to do so in a way that we think is easier to maintain in the code. It's easier to understand, which in my opinion translates to easier to fix bugs. And then on the front end, basically just simplifying that communication with the back end, whether it's Ajax or not. And overall, it gave us a huge simplification of the code base, and as a result, the overall logic. And we really want to like ClojureScript because it's nice to have one language for everything, if it's possible. And then testing for us seems easier. That's not necessarily a technical reason for that, but it's easier to convince people to round out the test suite and make sure that we're actually testing everything we're writing. And being able to share code between the front end and the back end, like the schemas as we're validating, becomes very useful to us instead of having to try to duplicate any of this. But we've had difficulties, and like I said, this is very new to us, and we're not 100% sure on what that development model should look like, and whether it's a coding style issue, workflow, and what the idiomatic way to accomplish various tasks is. And sometimes it feels like we're trying to fit a square peg into a round hole, and that comes down to how do we keep things idiomatic while at the same time still feeling relatively natural when it comes to UI development. And as you can tell by my background, UI is not something I've really thought about much except for an internship back in college. And so this could just be a lack of understanding on our part as a development team. And what it comes down to is we're using a lot of JavaScript objects to hold state, and we're just sprinkling them all over the place. And maybe that's related to how we're using knockout also, and there may be a better approach to that, I don't know. So if anybody has any comments, feel free. And so using them together, as I mentioned, we're using schema on both the front and the back end just to validate our just the data, the maps and whatnot. And when we were doing it with CoffeeScript, there was another piece of code to maintain, and by combining them, it became pretty simple to manage updates. Basically, we didn't have to do anything anymore. And so now that I understand kind of our workflow better, there's no reason why we couldn't call the validation functions from CoffeeScript or JavaScript or whatnot. And then from a development standpoint, kind of a more management perspective on this, by having the Clojure and ClojureScript intersection, it gives us the ability to move engineers around. You have a lot of stuff where on the back end you need a lot of particular knowledge, or on the front end the same thing, but there are a lot of tasks in the middle that you can move people around as you need and as your resource needs change. And so basically the language in this case provides that common abstraction for us for more effective resource management and being able to do more with less. And one of the problems that we're assuming exists, I guess, is that there's fewer developers generally to draw from, especially relative to Java and JavaScript. And we'll be hiring in the next 6 to 9 months, so if anybody's interested, feel free to ping me. So what? And basically, some of the conclusions we had in this sort of 6-month journey in Clojure is that we were able to increase our code density quite a bit. Whether it's good or bad, we don't know. But from a lines of code standpoint, we have about a 4 to 5x reduction. And one of the things here, it's a very rough estimate, and we're also adding in comments. And because we were new to Clojure, we felt we should add the comments, because without the comments, sometimes developers wouldn't understand what was actually going on in the code. And so if we're going to require comments, then we might as well add those because it's extra work. But as we get more experience and develop more institutional knowledge around this, we do expect this number to increase. One interesting thing we noticed was if you write a little bit of code, you're using a couple Clojure functions, and then you go away, you don't think about it for a couple weeks, or you hand it off to another developer. You have to relearn what happened, why you made a certain decision, why did you do things a certain way. versus actually making the change that you're looking to make, whether it's a bug fix or adding a feature of some sort. And we did notice that, at least perception-wise, it felt like it took longer to relearn code than with the more traditional object-oriented approach we had. But in totality, the time was reduced in terms of actually making the change, adding the test case for it, and then moving on. And so it was an interesting dynamic where it feels slower at first, but we think it's probably faster in the long run. And then that comes down to, just as I said earlier, doing more with less. And with fewer people, we seem to be able to do more. I joke that we'd still be creating or maintaining Java interfaces and a bunch of get and set functions, and then all the factories associated with that. And especially since at this stage in the game, we're moving pretty rapidly and constantly changing and learning better ways to capture the API. And so for us, that was really helpful. And then being able to lower this temptation to just do it and forego tests. This is, again, is not a technical issue, but one thing I noticed was that developers are happier creating test cases, or they're not as resistant to creating tests. And maybe it's because it doesn't feel as onerous, because if you're sticking to this functional programming kind of paradigm, your functions are very simple, so you know what your inputs are, you know what your outputs are, and it's really easy to create a test case around that. And you don't have to worry about creating these massive test suites just to test one function or one functionality in terms of the more traditional object-oriented approach. And so as a result, testing is much easier. Now, this is, again, not a technical comment, but an overall software engineering one, that if you can get people to create the tests and not get as much pushback, then I think that's a win. And so basically, we're committing to Clojure. We're on the fence about ClojureScript as a primary development language. And there are a lot of interesting projects out there for us to experiment with still. You kind of keep an eye on all these different projects, but we haven't spent any time looking at them, and we're very interested in some of the DevOps stuff out there. And so far, the community experience has been really good, and we're excited to be a part of it. And there's just a lot of options out there in terms of libraries. There's a lot of wrappers for existing Java stuff. There's completely native Clojure implementations of various functions. And the beauty is you use what you need, you ignore what you don't, and it seems easier to integrate bits and pieces of different Clojure libraries than in the Java world, at least in my experience. And we like the flexibility that we get with Clojure. Now, obviously, with that, you get time bombs, or you end up cutting yourself. And that's just a learning curve for us to figure out how to head off problems and prevent them before they happen. And it's unlikely that as a company, we would have made as much progress as we did without Clojure. And so that's sort of one of the reasons why I'm really excited about the language in general and kind of where the ecosystem is moving, is that we seem to be making a tremendous amount of progress in a short amount of time with few resources, and basically focusing on our time on what's hard and what matters, as opposed to just making sure everything plays nice together from an interface or an API standpoint. So that's all I have. If anybody has questions or comments, my contact info is there if you want to reach out for any reason.